First question, what is finite element method? Finite element analysis is a numerical method for solving physical engineering problem. Why we call this method as a finite element? Because it divides a large problem into smaller and simpler parts to run the analysis. To understand the finite element better, first we need to understand the concept of node and the concept of element. To understand the basic concepts of node and element, let's start with the example of a fence. As you all know, a fence is made up by either lots of sticks or lots of woods. Sorry about my drawing. I know it's not that good. I hope you guys understand. Okay, okay. Done. So in FEA, those small piece or blocks that makes the fence is called element. And now we want to fix the fence so that it doesn't move. So how we're gonna do it? We're gonna fix the fence in both ends, and especially where in real life we fix the junctions by rope or any other means. In FEA, those junctions where we define the degree of freedom is called node. Now I'm going to solve a very simple example for you. The problem, as you can see, it has three links. Bottom ends are fixed and one end it has 500 Newton force acting in x direction. Also, as you can see, the elastic properties are given. Its elasticity is 200 gigapascal and Poisson ratio is 0.3. So I'm gonna show you how much reaction force we're gonna get from these fixings and how the deformed shape look like. There are lots of finite element softwares like Ansys, Abacus, even SolidWorks has these options. For our problem, we're gonna use Ansys APDL Student version 2018. Let's get started. First, select what kind of analysis you want to do. Our problem is structural, so go to Preference and select Structural. So then go to the preprocessor. Let me tell you one thing. Preprocessor is something where we define every parameter to run the FA simulation. In FA, there are lots of element types. Depending upon the problem we are doing, you have to select the element type. For example, in our problem, the element type we're going to use is a link type element. So go to element, add, then select link, then press OK. Now we're going to define material properties. For that, go to material properties, go to material models, then select structural, then select linear because we are dealing with elastic properties. So we have to select linear, then elastics, and isotropic. What does isotropic mean? It means material definition is same in every direction. Then give the parameters we have from our theory. and click OK. Now we're going to define the area of the link. For that, go to section, then in link click add section number 1, then section name link, then define the area as 1 meter square. Now we're going to deal with the most important part of the FEA, the geometrical modeling. For our case, as you can see, we have 3 lines and 4 points. Let's define the points in an active coordinate system. For that, go to key points, then in active coordinate system, then define every points. Point number 1, the coordinate 0 0. Point number 2, the coordinate -1 -1. Coordinate number 3, 0 -1. Then coordinate number 4, 1 -1. Now we can add those points, and now we have the geometry ready to go. Now we're going to define the mesh. Go to mesh, then select mesh tool. Now one thing is that mesh property is something where we can define how many elements we want to have for run our simulation. In this case, the mesh are lines, so select the lines to define the number of elements. Now the number of elements for each link is 1. Because we're working with link, so it's better to have each link as 1 element. So press 1, then again go to mesh tool, click mesh, select 3 of them and press OK. Now the mesh is done. Now define the load. For defining load, go to load, then structural, then go to displacement, then define the degree of freedom or constrain the degree of freedom on node 2, 3, 4 in all direction. Then define the force at node 1 in x direction. So as in our problem, you can see in node 1 we have defined force in x direction 500 Newton. Once the definition is done, then go to solution and click. Now we want to see the results. We can see the results in each node or in each element. We can analyze the stress, strain, energy, force, displacement, etc. Now we want to see how deformed shape look like. For that, go to plot result and click deformed shape. Now we want to see the reaction forces in each element, each node. For that, go to reaction solution and you can see the reaction forces in each node. Once the analysis is done, then you can save the file. So thank you guys for watching the video. I hope this video will help you, and if you have any comments, please leave a comment below and don't forget to subscribe. Thank you.